Alrighty, so for question 56, we're going to compute the line integral of b. Check it using Stokes' theorem. So the 1.49 figure gives us this figure. So first, to compute the line integral, we have the path, and this is the first part of the path. So we're going to do v dot dl, and here we have x equals 0, y equals 1, z equals 0. We're going to do v dot dl, and the only thing changing is y, so our dl is just going to be dy y prime, and then dot that with v, so we get the integral from 0 to 1 of y z squared dy. And then we already said that z equals 0, so our integral for this first part is going to be 0. So for the second part, we are going to do the path between 0, 1, and 0, 2, 0, 0, 2. So we have x equals 0 here. Since we're changing our y and our z, we want to put 1 in terms of the other, so we're going to put all of our variables in terms of y. So to do that, we're going to use z2 minus z1 equals the slope of y2 minus y1. And then end up solving for that and getting z equals negative 2 y minus 1. And then we are also going to get, because we found our slope to be negative 2, our dz is going to equal negative 2 dy. Z hat. So using that, we are going to do v dot dl again equals yz squared dy plus 3y plus z dz. But we already solved for dz and z, so we can plug in for that again. And our integral for dy is going to be 1 to 0. And then we'll get integral of 1 to 0 y, and then we're plugging in z equals, so we'll get 2 minus 2y here. And then that's going to be squared, so 2 minus 2y again. dy minus, same thing, 1 to 0. And we're plugging in negative 2 for dy, so we're going to get, so the negative I'll take out here, and then we're going to get 2 times the quantity of 3y plus 2 minus 2y dy. So we'll combine those and just put both dy's at the end. So we're going to get 1 to 0 of y times the quantity of 4 minus 8y plus 4y squared minus 2y minus 4 dy. We'll fix that up a little bit and get 4y minus 8y squared plus 4y to the third minus 2y minus 4 dy. Simplify a little more. 4y to the third minus 8y squared plus 2y minus 4 dy. And then we will get, we can take out the 2 from this so we can integrate easier. We get 2y to the third minus 4y squared plus y minus 2 dy. And then now we'll integrate. So for integration, we're going to get 2 times the quantity of 2y to the fourth over 4 minus 4y to the third over 3 plus y squared over 2 minus 2y dy. Or nope, not dy anymore. It's going to be from 1 to 0 now. And then simplify this, we'll just change this to a 2 to make it easier. And then when we do b minus a, we're going to get 2 times the quantity of negative 1/2 plus 4/3 minus 1/2 plus 2. Times that all by 2, we have negative 1 plus 8/3 minus 1 plus 4 equals 6/3 plus 8/3. So solving the line integral for this b, we get 14/3. And now we're going to check our answer by using Oh no, sorry, we still have one more part of the path. This one will be easy as well. It'll be 0, 0, 2 to 0, 0, 0. So we get x equals 0, y equals 0, and then dl, since we're just changing in the z direction, is going to be dz z hat. We'll do v dot dl again, and we get from 2 to 0 of 3y plus z dz. So we know our y is 0, so we'll just cancel that out. So our integral will be z squared over 2 from 2 to 0, and then we get that to equal -2. Now to find the total integral of all of the line integrals added together, we're going to do 0 plus 14 thirds minus 2, which is going to give us 8 thirds. So this is our total for the line integral, and now we're going to solve it by checking Stokes' theorem. So Stokes is going to be del cross v dot dA. So we'll have x, y, z, and partial over partial x, partial over partial y, partial z, and then we have 6z squared 3y plus z for our v. So now doing del cross v, that will give us partial y of 3y plus z minus partial over partial z of y z squared minus partial x of 3y plus z plus partial z of 6 plus partial x of y z squared plus partial over partial y 6. So since none of these are in terms of the other, we can just cross those out, and we're just going to be left with 3 minus 2yz. So now, and that's in the x direction. So our del cross v is going to be 3 minus 2yz in the x direction. And now since it's bidirection, so we need to find del cross v dotted with dA. So our dA in the x direction is going to be dy dz x hat. And then in terms of our z and our y limits, our z limits are going to go from 0 to 2 minus 2y, because we solved for that earlier, and then our y is going to go from 0 to 1. So now when we do del cross v dot dA, we're going to get the integral from 0 to 1 and the integral from 0 to 2 minus 2y of del cross v dotted with a, which is going to be 3 minus 2yz dz dy, and I'll do dz first because it has the y in it. So now solving that integral, we're going to have integral of 0 to 1 of 3z minus z squared y from 0 to 2 minus 2y dy, and we're going to, when we plug in 2 minus 2y in, we're going to get 0 to 1 of 3 times the quantity of 2 minus 2y minus 4 minus 8y plus 4y squared all times y dy, and then simplifying that, we're going to get 0 to 1 of 6 minus 6y minus 4y plus 8y squared minus 4y to the third dy, and simplifying that even more, integral from 0 to 1 of negative 4y to the third plus 8y squared minus 10y plus 6 dy. And then we can take the integral with respect to y. So we're going to get negative y to the fourth plus 8y to the third over 3 minus 5y squared plus 6 y from 0 to 1. Plugging the 1 in, we're going to get negative 1 plus 8 thirds minus 5 plus 6, which equals 8 thirds, which is what we got when we solved the line integral. So we checked it with Stokes' theorem and it works.